Good evening, everyone, and welcome to Open Source Summit Korea. We're really happy to be here. We look forward to doing this event every year. Open source is growing all over the world. The Linux Foundation is growing, and here in Korea, the use of open source is growing everywhere. Today I want to make a few announcements. First, I want to thank our program committee who helped us go through all of the talks. We had a record number of talks submitted to this event. I hope all of you get to see the work that all the people who are presenting here this week have gone and done. I want to thank our sponsors, most notably KT Cloud, Tenstorrent, Microsoft, for all of their support. Today there will be speakers both in English and Korean, so if you want to get a translation assistant, please just follow the QR code here and captioning will be available on your device. So I'll give you a second to download the Wordly app. In addition, we have our solutions showcase right out front. If you can spend some time out there, we'd appreciate it. You'll find our sponsor booths. There'll be coffee and lunch served there tomorrow. And finally, join us tonight. It's our Tux Trek in the Solutions Showcase. There'll be drinks and refreshments and bites. We also have our LFX Mentorship Showcase. So for those of you who would like to participate in our mentor community or sign up for being a mentee, please go check it out. And then finally, if you stick around for all of the speeches tonight, we have a raffle at the end of our presentations tonight, a 150,000 won gift card and some noise canceling headsets. So please stick around till the end for a chance to win. We have two great speakers here tonight who will tell us all about what's going on in open source in Korea. But before that, I thought I would give a quick talk on what is going on around the world in open source. So how many people here are working on artificial intelligence initiatives at your company, or how many people here use artificial intelligence tools today? Almost everyone? Who doesn't use AI tooling? All right. You know, the Linux Foundation is home to a huge amount of open source projects. These projects range from cybersecurity to networking and telecommunications, to film and television production, to cloud infrastructure, to energy infrastructure, and much, much more. We have thousands of critical open source projects that run the vast majority of the world's infrastructure. You know, there are millions of open source projects out there, but it turns out there's a pretty small percentage of those millions of open source projects that are critical to industry and society, and those are the projects that the Linux Foundation really focuses on. And artificial intelligence is no exception to that. At the Linux Foundation, we're home to some of the most critical AI open source projects in the world. PyTorch is the de facto standard for building large language models. VLLM is one of the de facto platforms for inference and serving models. C2PA is a content provenance initiative that helps root out deep fakes, and many, many more. And as I travel around the world, everyone wants to talk about artificial intelligence. So let's talk today about what is going on, what are the big trends in open source as it relates to artificial intelligence. You know, 2025 has been an insane year in the world of artificial intelligence. How many people here got to meet Jensen Huang last week? He was just here in Korean, I think. Did anybody get to see him? I know he ate fried chicken. I hope someone can show me that restaurant. I want to go eat some fried chicken at the same place that Jensen Huang ate. What's so crazy about 2025, think about this. It was about 6-7 months ago where DeepSeek came out. This was a large language model, open source, that was pretty close to as good as ChatGPT. And do any of you remember this? NVIDIA stock dropped 17%. Everybody thought, oh my goodness, we've got these free, cheap models. It's going to totally change the economics of NVIDIA and artificial intelligence. Back then, even Sam Altman was sort of questioning OpenAI's position when it came to open source, sort of saying, hey, we may be on the wrong side of history and we need to change our whole strategy as it relates to open source. So back in February, how many people purchased NVIDIA stock when it was down 70%? One person there? All right. If you had purchased NVIDIA stock in February, you would have doubled your money. NVIDIA has more than rebounded. In fact, open source is, AI is so well capitalized. There's so much investment. There's such high values that now people aren't talking about open source. They're talking about an AI bubble. How many people have heard that there might be a bubble when it comes to AI? There might be too much investment happening, a few of you, in AI. That's the new conversation that people, literally over the course of 6-7 months, we went from, oh my goodness, open source is going to change everything, to, oh my goodness, we're investing too much. And so it is insane about how quickly the world of artificial intelligence changes from month to month and week to week, from open source commodity to AI bubble. And so today I want to talk about what's really going on. What do we really mean when we hear this talk of investment in artificial intelligence and maybe it's too much? And then equally importantly, why is open source so important in artificial intelligence investment? So the thing to think about, when I say that there's an AI bubble, what a bubble is like the dot-com bubble in the 90s, right? Where there's more investment than there is demand for services. So back in the late 90s, people thought the internet was going to be this huge thing, and e-commerce investment in infrastructure and web servers and so forth exploded. And there was too much build out, and a lot of dot-com companies went bankrupt because there just wasn't enough demand for an online pet store or kind of early stage web companies. And so the question is there insufficient demand for the amount of investment that's going into AI? And what I would postulate is that the demand for artificial intelligence is different. That the demand for intelligence is almost limitless. And in this era, the technology is different as well. Up until now, technologists like you built software and tools and platforms. Really, technology was about building tools, a spreadsheet, a cloud server, and so forth. But artificial intelligence is a little bit different. It's not just a tool. AI itself uses tools. So if AI is something that helps us be more productive, if it's more than a tool, and it really is intelligence, then odds are that the demand for that is incredibly large, far, far bigger than any normal technology demand. In addition, AI itself is becoming more sophisticated and more accurate, and the way that artificial intelligence is becoming better is through things like inference, thinking longer. And when AI thinks longer, it actually creates more demand for tokens, which is what is being produced when the AI is thinking, and that increases the demand for infrastructure and energy. And we're going to hear a little bit later from folks who are seeing this demand here in Korea. You see, the cost of all of this is just astronomical if you think of it. A venture capitalist in the United States, Bill Gurley, talks about building frontier models and the demand for compute infrastructure to train things like ChatGPT and Claude and the frontier large language models as the sport of kings. Sam Altman recently mentioned that the latest GPT-5 run was over $1 billion in investment to train. Just the other day, Anthropic, I think this was 2 weeks ago, announced that they were going to buy tens of billions of dollars, gigawatts of TPUs from Google in order to support their training. xAI is building a data center with hundreds of thousands of GPUs. This is an incredibly difficult game for anyone to play. Technology companies in the United States are spending billions of dollars just on training frontier models. In addition, inference, this is the thinking of a large language model, the thinking portion of the AI pipeline, is going up exponentially as well. This is just Google. In just about a year, Google is seeing inference go up more than 50 times. People are using AI more and more. AI is thinking longer and longer with inference, and therefore the demand for AI infrastructure continues to grow. One final statistic, just in the United States, just with the 4 largest hyperscale companies, the amount of capital expenditure in AI data centers is going to exceed the GDP of Portugal. It's up over $300 billion in collective spend just this year. In fact, Jensen, who was here last week, said in Washington, D.C. the week before that he had the line of sight to $1 trillion in GPU sales through 2027. In other words, every company that is supplying infrastructure for AI is seeing far more demand than they actually have supply. And the more demand for AI model development and inference, the more demand there is for energy and power. It's really very strange to think that today, the number one thing constraining growth in artificial intelligence is actual energy, electricity. Just the other day, Amazon's CEO mentioned that this is their single biggest constraint, access to electricity to meet the demand for AI infrastructure. So this so-called AI bubble is primarily an infrastructure story. It is an incredibly expensive race to build massive data centers in order to meet the demand for artificial intelligence. And NVIDIA is at the center of this, selling trillions of dollars of GPUs in order to meet that demand. And yet, with all that hardware demand, this is just, again, from Washington, D.C. last week. I was at this event, and Jensen presented how important open source is to NVIDIA as well. So what is it about open source that makes it so important that Jensen wants to talk about it when he has over $1 trillion worth of sales of GPUs in his forecast? What is it about open source that matters? Well, everything I've described till this point, the big AI spend, is primarily been at this level of the AI stack. Power and electricity and GPUs and data centers, building out these AI factories, We're seeing this here in Korea, we're seeing it in the United States, we're seeing it in China, we're seeing it in Japan, all over the world. But obviously, there's more to the AI stack than just the infrastructure and hardware layer. To build AI applications, you need models and you need software. And this is where open source comes in. Because eventually, in order to realize all of the demand for this hardware and AI factory infrastructure, you need applications that people can buy in order to recoup that investment. And this is where open source does extremely well. So today, we're seeing this constraint in hardware and electricity and in data center infrastructure. But that will soon change for demand for software applications, for software infrastructure, both to realize the value of this investment, but also to make the underlying hardware investment more efficient so that you can get more tokens, so that you can get more results, so you can get more efficiency out of that hardware investment that I've been talking about. And this is where open source is really, really good at getting the most value out of the hardware infrastructure that everyone is investing in. So first of all, open source has played a critical role in making frontier models cheaper. The amount of work that's going on, both in the United States with GPT-OSS, Llama, in Europe with Mistral, and most importantly in China with models like DeepSeek and Qwen, all of these open models are basically bringing the cost of training down at the frontier. And unless you're a company like OpenAI or Anthropic or Google or Microsoft, taking advantage of these open models and distilling smaller models from them at a significantly lower cost is a way to keep up with the game when it comes to artificial intelligence. Open source AI front models have largely caught up with closed AI models on evals. Like generally, the open models are about 90–95% as good as the frontier models, but of course, they're freely available for anyone to use. So in terms of price performance, these models have caught up, and today the real measure of new frontier models isn't just how well they perform, but it's how well they perform relative to their efficiency. And so this is a good example of kind of where the world is going in a electricity and hardware constrained world, where everyone's trying to catch up on investment in hardware and electricity. You need the most efficient models possible to run in your infrastructure. And you can see here the most efficient models in terms of cost per token, per watt, are open source models in general. My prediction is that the more you see the diffusion of open models out there, the more energy efficient, the better price per token, per kilowatt these models are going to become. I think in the United States, in the next 6 months, you're going to see more and more open weight models come out that meet this demand. Because remember, we're investing a lot in building out hardware and energy, but at the same time, we need to make the most of that hardware and energy because we just don't have enough of it. We're also seeing the rise of specialized models built on open source software to get the most out of AI infrastructure. Today in the United States, we're seeing open source inference engines and deployment technology managing hundreds of ML and LLM models in a single organization's infrastructure. My prediction is that most enterprises are not going to use one giant model, but they'll use hundreds of smaller, fine-tuned open source models for very specific tasks, such as sentiment analysis or maybe code generation or contract review. This is what the future will look like in a world where you're trying to get the most out of your AI data center footprint. And open source is incredibly good at that. This is why it matters. Open source specialized models are cheaper to run, they're just as performant, they have lots of varieties of hardware that they run on, and they can be built on-prem in order to assure privacy guarantees. Think of it this way, I like to call it the 90-90 rule. These models are about 90% as performant as the biggest frontier models out there, but they are 90% cheaper and efficient to run in your AI infrastructure. And that is the sweet spot where we're seeing incredible adoption from enterprise to enterprise in the United States. So let's talk a little bit about, beyond the models, about the software infrastructure we use to deploy these models. Today, this is what a typical simplified deployment model for AI infrastructure looks like, whether you're doing training, post-training, serving, or building AI applications. The boxes in blue are all Linux Foundation projects, we're proud to say. People train using PyTorch, they deploy using things like VLLM and DeepSpeed, they orchestrate using Ray and Kubernetes, and Linux, which is that small box underneath, powers all of this infrastructure, of course. What's really interesting is that open source is really, really good at squeezing more power or price per token per kilowatt than anything else. Here are a few examples. If you use VLLM, we've seen efficiency increase in inference up to 400% improvement. So think of that. If the collective investment in data center infrastructure is $300 billion, wouldn't you like to make that infrastructure 400% more efficient? That's how you can keep up with all of the demand for this AI infrastructure. DeepSpeed improves GPU efficiency by 400 to 600%. This is the sweet spot for AI infrastructure where we need this kind of efficiency. And so what you're going to see is open source continue to focus on these efficiency gains at the software layer as hardware gets built out across the world. But what really is the next stage for open source, for AI? Where are we going to see even more demand that keeps up with this huge build-out? Today, there are a few pillars of AI. There's training and building models. There's inference, serving the models and doing advanced tasks, thinking, reasoning, and so forth. And at each of those stages, you want to have efficiency in training, you want to have in deployment, speed, less latency, token efficiency, and so forth. And that's what open source is working on today. In the next year, you're going to see the third pillar of AI emerge around agents. Today, we're at the very beginning of the agentic AI story. When agents start being deployed as a tool to make organizations more efficient, you're going to see, again, a massive increase in demand for AI infrastructure and tokens. Because remember, building a model is expensive. Inference, the longer AI thinks, is very expensive. But with agents, you have multiple agents thinking longer, and the demand for tokens, the demand for AI infrastructure goes up even greater and more exponentially than it has to date. We're at the very, very, very beginning of this. So how can open source help in this new world? Well, as I've already shown you, in training and inference, what open source does the best is squeezes every dollar out of that expensive infrastructure. And with agents, you're going to see the exact same thing. Today, the Linux Foundation is home to the A2A protocol. You're going to see even more open source projects come out of the Linux Foundation. that help to establish standards and protocols in order to make this agentic era of AI a reality. And what this will do, again, is what open source is very good at, which is it will create more efficiency in agent infrastructure and lower the cost of deploying agents and push value up to the application layer, to the usefulness of those agents, which is, of course, where all the value comes from. So I think open source is uniquely suited here to dance on the bubble. If there is a bubble, which I'm pretty skeptical of, I think that the demand for AI infrastructure is real. What open source is going to do on top of all of that AI data center build out, all of those GPUs, is make them far more efficient, build the market faster, because as we know, eventually, as Mark Andreessen likes to say, software eats the world, and in AI, open source will eventually eat that world as well. So I look forward to coming back here next year and seeing if any of my predictions have come true in terms of breakthroughs that we'll see in model efficiency, in inference efficiency, and in AI adoption enabled by open source. So with that, I want to thank you and introduce our next speaker. If you have any questions for me, please don't hesitate to come up and talk to me after our presentation. So thank you very much.